Hi, we're working on part 2 of the project, and from part 1 you have the research question and the survey questions. So when you're doing part 2 of the project, it's really pretty much a cut and paste from part 1 of the project to identify what your group was interested in. That's the research question, and then what the survey questions actually are. In terms of the summarized results, you can just submit like a small table for the categorical variables that would show the counts for each of the different categories for your categorical variables. So in the practice data set, the categorical variables are political party and gender, and so I have a little table here that shows the count, which is the number of individuals for each of the different parties and each of the different sexes. And these tables, by the way, I had made those in Excel. Oh, yeah, it's just if you have in Excel, cells that have the category names and the numbers, you can just copy those, select them, copy and paste them into the Word document, and you can get those. For the quantitative variables, the summary, what I did for this is I did descriptive statistics for the quantitative variables. So on my spreadsheet, the quantitative variables are hours and age, and so you can look on Canvas. There's a link under working with quantitative variables with Excel, and if you do that, you can get the descriptive statistics and get these outputs. So once you do that, you can just copy and paste that into the Word document as the summary for the quantitative variables. Now we also did, previous to this time, we did the pie and bar charts for each of the categorical variables. So for the political party, for this fictitious data, we see the percentage of Democrats and Republicans, pie chart and bar chart, and then for the other categorical variable, we have the same. We have the same charts. We have pie and bar charts. So I'm not doing those things now. What I'm doing in this video is the confidence interval estimate for the proportion. So in this fictitious data, this was a survey of, it was a fictitious survey of students at Middlesex County College. So that's the population. The population is the students at the college. And so in the project, you want to do a confidence interval estimate for the proportion. In other words, the proportion of either, you pick one of the categories of your categorical variables. So for example, if I look at the gender variable, I'm going to do an estimate for the proportion of females. And for the political party variable, I'm going to do a confidence interval estimate for the proportion of Republicans. I could just as well have chosen Democrats. I could just as well have chosen males. But you don't need to do 4 confidence interval estimates. I'm just doing one confidence interval estimate for each categorical variable. Okay, so again, I picked, I'm going to do females. And so I have here the, I took this from a Penn State site, and it's just the formula for the confidence interval for the proportion. It's the sample proportion plus or minus a z-value times a standard error, and the standard error is given by this expression. It's the square root of this sample proportion times 1 minus that over n. So I'm going to do this calculation. I think I'm going to do this calculation in Excel, and then I'll just copy and paste the result here, and then I'll just put a sentence to summarize. And I started my summary sentence here, and the summary sentence starts with, we're 95% confident that the proportion of female students at Middlesex County College is in the interval. I have to fill that part in because I haven't determined the interval yet. But so I will have a summary sentence at the end of this. Okay, so how do I do this? Well, so I just need the sample proportion plus or minus this expression. So the sample proportion, the notation we're using for that in class is p hat. Oh, whoopsies. Is p hat. Let me move this over. So the sample proportion for females, if there's 100 total and there's 52 females, then the proportion of females is 0.52. So I have 0.52 in here. And now I need the Z value. So the Z value is that value of Z. If I want a 95% confidence interval estimate, it's symmetric about the mean. So I'm going to put 2.5%. I need the value of Z that puts 2.5% of the area in each of the tails. Right now, since the standard normal is a symmetric distribution, I want this value to either be 2.5% in the lower tail or 2.5% in the upper tail. If I use the lower tail, my Z value will be negative because the standard normal is symmetric about 0. If I use the upper tail value, then that value will be positive. And you could use either one. It actually doesn't matter. If you use, since we're adding and subtracting this, then it really wouldn't matter. I mean, if you use the negative Z value, then when you subtract, you'll get the upper bound of the confidence interval, and when you add, you'll get the lower bound. So that's fine. I don't think I'll do that, though. I think I will get the positive Z value. And in order to do that, then I want 2.5% in the upper tail. So 2.5% in the upper tail. Well, so then how much would I have to the area left of that? That would be 97.5%. So the probability value for that Z would be 0.975. Okay, so how do I find that? So there are distributions that are stored in Excel, and so if you want to get one of those on your spreadsheet in a cell, you have to press equals, and then you can use one of the functions. Okay, so the function that we want is, well, we'll find it. If you click on f of x, actually I just checked it out a moment ago. It's a norm inverse, but if that's not in your recently used functions, you could go to all, or you could go to statistical. So if we go to statistical, it's going to be in this list. We want inverse. So where is it? Oh, okay, so norm inverse. So this one. So it says norm inverse returns the inverse of the normal cumulative distribution for a specified mean and standard deviation. So that's what we want. So if we do norm inverse, the probability, again, to get a positive Z value, then I'll use the upper tail. So the probability value would be 0.975. And this is the standard normal, so the mean is 0 and the standard deviation is 1. And if we say OK, then the Z alpha over 2 is this 1.9599. And if you use your calculator, you'll get the same value to this many digits. There's more digits that are possible, but this is fine. Okay, so now that's the Z value. So the margin of error is this whole expression. The margin of error is the Z value times the square root of this expression. So I'm going to do that calculation in Excel as well. So I'm going to do equals. And so to do the calculation, I need the Z value. So I'm just going to click on the cell that has the Z value and then multiply by, now square root is a very simple Excel function. It's SQRT. So you get SQRT, and I'm going to put in a left parenthesis, and then I'm going to click here in the formula bar, and I'm going to put in the rest of the expression. So I want the square root of p hat, so I'll click the cell for p hat, times, and now I need 1 minus p hat, so I'll do that in parentheses. So I want 1 minus p hat, and again, p hat is this cell, so I'm just going to click that cell. And then I close that parenthesis, and I need to divide by n. So I'm going to divide by my sample size, which is 100, and then close that parenthesis. So you can see the parentheses have to be balanced, it's like function notation, really. Square root's a function, and everything that's inside the square root, right? The sample proportion, 1 minus that divided by n, all of that has to be in the parentheses for the square root function. So this is the formula. This is the formula for the margin of error. So if I hit enter, the margin of error here is pretty small. It's less than 0.1. So pretty small. Okay, so now that I have the margin of error, I can calculate the confidence interval estimate. I need the lower bound and the upper bound. So I will identify those. In fact, I think I'll move this. So I'll have the lower bound and the upper bound of the interval. So the lower bound of the interval, that's going to be equal to the sample value minus the margin of error, and we just did that calculation. So click on that cell and then hit enter, and then the upper bound will be equal, that's going to be equal to the sample value and then plus the margin of error. So these are the bounds for the confidence interval estimate. And I'm going to just copy and paste this into the Word document so that I can show, here's the work that I did. This is what it is. So I'm going to center justify it and then just copy and paste that here. Of course, it didn't center justify, but I'll try that again. So it's now center justified. Okay. So we're 95% that the proportion of female students is in the interval from, say, and if I round to just give it 2 decimal places, that would be 0.42 and 0.62. So in other words, between 42 and 62%. 42% and 62%. And that's it. That's all there is to it. So hopefully you can now do the confidence interval estimate for your proportion in Excel, and it should be pretty straightforward. Okay, thanks.